Okay. Dear students, today we will study the topic fuels and refractories. Before going to the real topic, I will tell some important things. Okay? Okay. So this is the topic which we will study today. That is difference between LTC and HTC. What is LTC? What is HTC? That we should know. First, I will tell what is LTC. LTC means low temperature carbonization. What is HTC? HTC means high temperature carbonization. First of all, you must know what is carbonization. What is carbonization? Carbonization is a process through which we will make coke. That is called coke making. What is coke making? Coke is produced by a process called carbonization. Okay. So what is carbonization? You must know what is carbonization. Heating of coal in absence of air to produce coke is known as carbonization. So this is carbonization. And carbonization are generally two types. One is low temperature carbonization and other one is high temperature carbonization. Okay, low temperature carbonization and high temperature carbonization. Then we will know what is low temperature carbonization. Low temperature carbonization. Generally, this carbonization is carried out at around 700 degrees centigrade. At around 700 degrees centigrade. Just see, it is carried out at around 700 degrees centigrade. That's why it is called low temperature carbonization. Then it produces semi-coke for the use as smokeless domestic fuel. And here the content of tar is high, that is about 10% of the coal used. The calorific value of coke oven gas produced in low temperature carbonization is more due to higher percentage of volatile matter, that is 600 to 6500 kilocalorie per meter cube. Then comes after carbonization. After carbonization, discharging of coke is difficult. Discharging of coke is difficult as it swells a lot but does not shrink much. Finally, at the end of the cooking, due to low temperature carbonization, due to less shrinkage, coke produced is bigger in size, weaker and more reactive. And here the volatile matter content is more, that is 5 to 7%. Hence it is easier to ignite and ignition. Okay. So this is all about low temperature carbonization. So it is very important to remember that the low temperature carbonization is carried out at around 700 degree centigrade. Okay. Okay. Next, next we will go to high temperature carbonization. So what is high temperature carbonization? The the carbonization process which is carried out at 1000 degrees centigrade. It is called high temperature carbonization. And what are the most important aspects of this high temperature carbonization? It produces metallurgical coke for the use in different metallurgical furnaces. The coke that is used in the furnaces are produced by using this high temperature carbonization process. Then the content of the tar here is 3% of the coal used. 3% of the coal used. Then the calorific value. The calorific value of coke oven gas produced is very low. That is 4,200 to 4,400 kilocalorie per meter cube. Then discharging of coke is easier here as it sinks finally to a more extent comparatively due to higher temperature of carbonization. Then here the most important aspect is that the coke produced in high temperature carbonization process is stronger and smaller in size and smaller in size and less reactive due to higher amount of shrinks Okay students, this is very important aspect of high temperature carbonization. Okay. Then the volatile matter content is very low. The volatile matter content is very low. In case of low temperature carbonization, what was the volatile matter content? It was 5 to 7%, which is considered to be high. But in this case, in high temperature carbonization, the volatile matter content is very low. That is about 1 to 2%. That is about 1 to 2%. Hence, it has high ignition temperature. Hence, it has high ignition temperature. That is around 600 degrees centigrade. 600 degrees centigrade. Okay. So this is about your high temperature carbonization. Students, you must remember that this low temperature carbonization, which is LTC, and high temperature carbonization, which is HTC, is very important. And for examination point of view, you must remember it, you must understand it, because it is an important part of this fuel and refractory subject. Okay. So students, this is all about the difference between low temperature carbonization and high temperature carbonization. Okay. Next, students will go to another important topic. What is that? Hardness and strength. Hardness and strength. Hardness and strength. Hardness and strength. What do you mean by hardness? What do you mean by strength? Okay, that we must know. So first, we should know what is hardness. What is hardness? Hardness is defined as the resistance power of material to breakage by impact. What is hardness? It is the resistance power of material to breakage by impact. Okay. Then strength. How you can measure the strength of coke? How you can measure the strength of coke? How can you know what is the strength of that coke? Okay. Strength of coke is measured by two important parameters. Two important parameter. Okay. That is called, one is shatter index, then other one is Micom index. The other one is Micom index. Through these two parameters, one is shatter index, another one is Micom index, we can measure the strength of coke. Then comes, you can ask, how can you measure the hardness? Yes, this is also important. Hardness also, hardness also is measured by a parameter called Micom index. So in Micom index, what you can do, you can measure both hardness and strength of coke. In shatter index, you can measure only the strength of the coke. So this is the difference. In shatter index, you can measure the strength of the coke. In Micom index, you can measure the strength as well as hardness of the coke. Okay. Then what is shatter index? You must know what is shatter index. Shatter index measures the resistance of coke to breakage by impact. It measures the resistance of coke to breakage by impact. Okay. Suppose you take 50 pound of 2-inch size coke, 50 pound of 2-inch size coke in a rectangular box of dimension 28, 18 and 15 inches. This box is placed 6 foot above a steel base plate of half inch. The materials are realized from the box and is dropped on the base plate. Students, this is all about how to measure the shatter index of the coke. We are going by this process. Coke is then screened through a series of sheets made of square stamped sheet. The percentage of coke retained on 2-inch, then 1.5 inch and half inch sheets are recorded and called shatter index. The desirable value of shatter index for blast furnace coke and 2-inch screen, 90% on 1.5 inch screen and 97% on 0.5 inch screen. Okay. Then comes Micom index of coke. What do you mean by Micom index? And what is the importance of Micom index? Students, already I have discussed about shatter index. Now it is also important for you, Micom index. This gives the hardness and strength of cokes. How you can measure? How you can measure? 50 kg of coke of 50 mm size is rotated in a Micom drum for 4 minutes at the rate of 25 rpm revolution per minute. Micom drum is a cylindrical steel drum of both length and diameter of 1 meter. The length is 1 meter the diameter is also 1 meter. The drum is fitted lengthwise with 4 angle irons. That means there are 4 angle irons which is fitted into the drum. After rotating, the coke is taken out and screened through 60 mm, 40 mm, 20 mm and 10 mm round hole screens. Okay. So what you are using here? 60 mm screen, 40 mm screen, 20 mm screen and 10 mm screen, and the holes are round shape. The holes are round shape. This is important, not rectangular. The holes are round shape. The next is the percentage of coke retained on 40 mm screen is called M40 index. Remember students, the percentage of coke retained on 40 mm screen is called M40 index. M40 index means Micom 40 index. Whereas the percentage coke that passed through 10 mm screen is called M10 index of coke. M10 means Micom 10 index of coke. M40 gives the resistance of coke to breakage by impact. M40 gives the resistance of coke to breakage by impact. That is, it gives the strength of coke. Remember, M40 gives resistance of coke to breakage by impact. That is, it gives the strength of coke. Whereas M10 gives the resistance of coke to breakage by abrasion. M40 gives the resistance of coke by breakage by impact. Here the resistance of coke to breakage by abrasion. So it means high M40 and low M10 values are desirable. What we can conclude here, high M40 and low M10 values are desirable for metallurgical coke. So high M40 and low M10. You must remember it. So students, what we have studied today, what is low temperature, what is first we have studied what is carbonization, what is the definition of carbonization, what are the types of carbonization, low temperature carbonization and high temperature carbonization, what is the difference between low temperature carbonization and high temperature carbonization. Then what next we have studied? We have studied what is the strength of coke, what is the hardness of coke, and how we can measure the strength of coke and hardness of coke. For measuring the strength and hardness of coke, we have used two parameters. One is shatter index, other one is Micom index. What is shatter index? We have already discussed. Then what is Micom index? Now we have studied Micom index is mainly M40 and M10. What is M40? What is M10? We have discussed now. M40 means the resistance of coke to breakage by impact. M10 means the resistance of coke to breakage by abrasion. Okay. So these things we have studied today. In the coming class, we'll go to another topic, another important topic, which is very important. Okay, students. So this is all about today's class. Okay, students. So then we'll discuss the next topic in the